Hello everyone. In previous video, for this example, we had discussed first come first serve algorithm, scheduling algorithm. And now we have to move towards the next algorithm, that is the shortest job first. As the name itself, it is indicating shortest job first, means it will be focusing on the burst time. So by comparing the burst time, which process burst time it will be very less, that it will be having the more priority. According to this, it will go for the increasing order of the burst time here. So here we have a first we need to find out, it is given five processes are given here, and arrival time of the each process it is given, and burst time of each process. Then we have to find out the completion time of the process. So P1, and actually here it is a shortest job first, which is a minimum here, that P3 it will be having the minimum burst time, but its arrival time it is a T, it will comes at the third unit. But first starting always the process it will starts its execution from the zeroth unit here, initial unit. At the zeroth unit, P1, only P1 it is arrived. No any other process it had come here. And once P1 comes at the zeroth unit means it is a non-preemptive. Here we have a FCFS. It will be having two properties here, non-primitive as well as primitive. Non-primitive in the sense, once the process is allocated the processor until to complete its processing time, that is a burst time, it cannot leave its control to the next process. Means until unless completing that particular process which is under the execution, it cannot allow other process to enter for the execution here. Even though it is a higher priority, it cannot be bothered. That it is called as a non-preemptive. Preemptive in the sense that here any higher priority process it will comes means that executing process it will be leaving its control for the higher priority process. Now it is a non-preemptive here, and in the zeroth unit, even though it is having the maximum burst time, that is processing time, execution time, then also at zeroth unit no other process will be coming. That's what here it will be starting with the process P1. In Gantt chart, I can take P1 here, and then P1, how much time it will be taking? 0 to the 6 unit it will takes here. So now here it will be taking the 6 unit. So now I'll select this one. Just a minute, I'll make the alignment here. Here, with the big size. Let me take a little bit big and bold. Okay. So here we have a P1. It will be started from 0 to 6 it will takes. When P1 it is completed, the time for the completion of the P1 it will be 6. And then next it will takes, now P1 it is completed, remaining. Among these we have to find out the shortest time, for which the shortest execution time that it will be taking for the execution, P3. P3 it is having very less time for the execution. That's what P3, it will starts at the unit 6, and it will be taking only 1 unit for the completion. So when P3 it is completed, its time will be 7 unit. Then next, after P3, the next minimum shortest job is the P2. So P2 it takes for the execution, and its time it is burst time 2. That's what from 7th unit it will starts, and up to completion of 2, that is 9. 7 plus 2, 9 it will takes. So then next highest priority goes to P5 with a minimum burst time. That is P5, and it will be having 8 unit here, that 16 plus 17 unit it will be taking. And then next we have a last one, it is a P4. So P4, it will takes its unit 8, burst time it will be 8 here, that is 26, 20, 5 it will be taking. So 17 plus 8, 25 unit it will takes. So this is the Gantt chart with respect to the SJF. This is a non-preemptive. That's what here P1 it will be taking at the 0th unit, and up to 6 unit it will take the execution of the P1 itself. When 6 units are completed, all remaining processes are arrived for the execution. That last maximum time taken to arrive is 5 here. Within 6 unit all are arrived. So we have to compare the burst time among all these, minimum to maximum, that we have to take, and we have to complete the completed time. We have to find out the completed time of each process. Then now here we have a P1 it is completed at unit 6, and P2 it is completed at the unit 9, and P3 is completed at the unit 7, and P5 completion time it is 17, and P4 17, and P5 it is 25. So this is the completed time of each and every process. Then next we have to go for the turnaround time here. Turnaround time is nothing but a completion time minus arrival time. That I'll be taking for this table. Here it is. Completed time is 6, and arrival time it is 0. 6 minus 0 it will be 6 here, and then 9 minus 2. Completed time is 9, and arrival time it is 2. We need to focus on these two columns. 9 minus 2 it will be 7 here, and then 7 minus 3 it is 4, and then 17 minus 4 it will be of 13. 17 minus 4, and then we have a 25 minus 5, it will be 20. This is the turnaround time. Then next we have to find out the waiting time. Waiting time will be calculated with that turnaround time minus burst time. Turnaround time including with the burst time also, as well as extra waiting time also. We have to separate the waiting time from the turnaround time here. So the formula for the waiting time is turnaround time minus burst time here, that I'll be taking for this column. Okay, so here we have a waiting time. It is turnaround time 6, and then burst time of this it will be 6. 6 minus 6. Now we need to focus on these two columns. So 6 minus 6 it will be 0 here, and next 7 minus 2 that will be 5, and then 4 minus 1 that is 3, and then 13 minus 9 13 minus 9 that is 4, and then 20 minus 5 is 15. Sorry, 20 minus 8. Here we have a just a minute. 13 minus 9 it will be 4, and 20 minus 8 it is 12. Okay, so here we have a calculation of the turnaround time and waiting time for each and every process it is. What is the turnaround time for the P3? That is 4. What is the waiting time of the P4? That it will be 4. Like this, we can find out the individual calculation of this. Then now here we have a average turnaround time as well as average waiting time. This one here we have a average turnaround time is nothing but 6 plus 7 plus 4 plus 13 plus 20. This divided by 5. This whole thing divided by 5 here, because number of processes are the 5. So here we have a 12, 13, 17, 20, 30, 40, 50. This is a 10. This is equals to 10 unit. It takes the 10 unit, 20, 33, 37, and 44 and 50. Okay, now it will be 10 unit here. And like that only, here we have a average waiting time. Average waiting time is the sum of all these divided by 5. That is 5 plus 3 plus, okay, let me calculate this one here only. 5 plus 3, 8 it is. 8 plus 4, 12, 24. 24 divided by 5. This is equals to 2.4. That is 2.4. Sorry, 2.8. Wait. This is 5 fours are 24.8 it is. Okay. So this is the average waiting time. This is the turnaround time and this is the waiting time, average waiting time. Just we have to compare here. Average waiting time, it is a 4.8 here in SJF. And here in case of the first in first serve, it will be 2.12. And here it is a 4.8. 4.8. And here it will be of the 10. Just a minute. Here it is 4.8, and in the previous algorithm, it is calculated with 2.12. How come it is possible? I think in the calculation it will be wrong here. 5 fours are 20 and 10 are 23, 25, 5s are 25. Okay, here we have to make it 5. 5.4 something it will comes. Oh, this is 5.4 and this one it is correct. Okay, 10.6. Then now here we have we have to compare both the algorithm. In this it will be 4.8 waiting time. It is the average waiting time for the same example. It is 4.8 and in case of the FCFS it will be of the 5.4. Then which one is the efficient? Here we have a SJF, it will be efficient as it is having the minimum waiting time. Now it is of the non-preemptive. Like that only, we have to go for the preemptive algorithm here. Preemptive, how it will be working. For the same algorithm, we'll take the preemptiveness here. And just here, I'll be copying the slide. I'll duplicate this one. I'll go for the changes. Now it is a non-preemptive that I'll remove and I'll go for the preemptive. In preemptive algorithm, actually here that everything it will be going to change. I'll remove this one. According to preemptive algorithm, I have to take the values. Okay. So here we have a Gantt chart also. In the 0th unit, P1 it will be coming, and P1 it comes at the 0th unit, but maximum burst time it will be of the 6. And before completion of the P1 6 unit, the P2 it will be coming, which is having the higher priority. So if it is taking from 0 to 2 unit here, P1 it will be completing up to 2 unit. And at the second unit P2 also it is coming. Remaining time of the P1 it will be 0 to 2 means remaining time it will be 4 and P2 it is having 2. Among these two, the P2 it will be having the higher priority which is required the minimum time for the execution. That's what now after 2 unit of the P1 it will be starting with the P2 and P2 will be completing with the 1 unit here. The P2 it will be completing with the 1 unit first. And after by completion of the 1 unit, 2 plus 1, it will take 3. Okay. Now it will be taking the unit 3 here. Here we have a 2 unit. In that 2 unit of the burst time, 1 unit it is completed and remaining it will be 1 unit. And at the time of 3, P3 also it is coming. And P3 time requirement, that is burst time, it will be 1 unit. Now P2 also it is having the 1 unit and P3 also it is having the 1 unit. That's what P2 it will be completing its entire execution up to 4 unit. The P2 it is completed. That by 4 unit means this P3 also it is coming and P4 also it is coming up to 4 unit. So P3 it is having the 1 unit and P4 it is the 9 unit. If we compare these two, P3 will be having the less processing time, that is the burst time, higher priority. So next it will be continued with the P3 here, and P3 it is having only 1 unit of execution here. That's what it will take the execution, 1 unit, that is 4 plus 1, it will be 5. Then next we have a P3 it is completed and up to 5 unit means all arrived here, and P4 and P5 are there, and now P4 it is having 9 unit and P5 it is having 8 unit, but still we have a P1. P1 it is not completed its execution, only 2 unit it is completed. By 2 unit means that higher priority with the less burst time, P2 it will be coming. So it will be leaving its control for the P2. Now here we have a P1 remaining time, it is a 4 unit here. And P4 it is 9 unit and P5 it is 8 unit. Among all these, the P1 it will be having the minimum time. So here it will go for the P1 remaining time of the P1, it will be 4 unit. 5 plus 4, it will be 9. 5 plus 4, it takes here 9. Then next here we have a, next it will be taking P4, P5. P5 it is having only 8 unit here. That's what it takes here, P5. And P5, how much time it is required for the P5 means 8, 16, 17. Up to 17 unit it will take the execution. Now here it will be completing with the 17 units. So one more column we have to insert here. Here I'll go for insert column to right. Okay. So in this remaining, one more it is there, that is the P4. P4 it will take here. P4 and P4 time it will be 9. So 17 plus 9, it will be of the 25. 17 plus P4 it is a 9 here. So it is of 20. What is the previous Gantt chart? It should be same for both. Somewhere we are missed here. The first one 2 unit plus 4 unit P2 and P3 it is 5. And then again remaining time of the P1 5 plus 4 it will be 9. 9 plus P5 P5 it will be 8 here. That is 9 plus 8, 17. 17 plus 9, P4. P4 it is of the 9 here, burst time. So here we have a, just a minute, I'll check it out. Okay. Here we have actually in this, the Gantt chart, it will be coming up to 17 plus 8, 17 plus 9, that will be of the 26. 26 it will comes. And one thing you have to remember, the Gantt chart of this each and every algorithm last unit, that after completion of all the processes, the last value what it will comes, it will be same for all the algorithm. Now in the previous algorithm it is 25. Somewhere it is missed that actually here we have a 17 plus 9, it will be of the 26. I have written here 25. This calculation it will be 26 here. And now it is 26 means this also have to make 26. And 26 minus 8, it will be of, here we have a completed time minus arrival. 26 minus 1 means it will be 21. And this one, it is turnaround time minus 21 minus burst time. Here also we have to increase with the one number, and here also we have to increase with one number, that is 25. So here it will be of the 5. It takes 5. And Gantt chart, it will be of the 26 in the SJF, previous SJF. Like that only we can compare the previous one, that is the first come first serve. Now this is also 26, and here this is also 26, and this one also it will be 26. It is of the preemptive. Then now we have to go for the calculation of the completed time, turnaround time, as well as waiting time. So completed time for the P1 is 2 unit, 9 unit. Because here P1, remaining part of the P1, it is taken 9. So now this is the difference here, preemptive and non-preemptive. Just you have to notice, in case of the non-preemptive, the first P1, it is taken from 0 to 6. Even though that next all remaining which are having the higher priority, some of the higher priority processes are arrived before completion of that P1, it is not allowed to execute those until to complete its fullest extent of the time, how much it is given for the execution. This is a non-preemptive, means any remaining part of the P1, it is not interleaved, it is not continued somewhere. Like that, nowhere there is a interleaving operation we can notice. And like that only, when we'll come to the preemptive, here we have a 0 to 2. When it is completed 2 unit, at the second unit, here we have a higher priority process, it will comes. That's what P1, what it will do, it will goes to the waiting state, and it will be allowing for the P2 for the execution. And from there, it will comes to the ready state, and it will be continuing with the next process. When it will gets its priority, it go for the execution. This, it is a preemptive execution here. So now P1 2 unit, it is completed here, and complete execution of the P1, it will be here. That is for the 9 unit. We have to take 9 unit for the P1 here, and P2 will be completed at 4 unit, and P3 it is completed at the 5 unit, and then next we have a P4, it is completed at 26th unit, and P5 is completed at the 17th unit. Then now turnaround time, completion time minus arrival time. This is 9, and then next one 2, 4 minus 2, 5 minus 3, 2 it is, and 26 minus 4, it is 22, and 17 minus 5, it is 12. And like that only, waiting time, that is turnaround time minus burst time. So turnaround time, it is a 9, burst time, it is a 6. 9 minus 6, it will be 3. We need to focus on these two columns, this one and this one. So 9 minus 6, it will be 3 here. And then 2 minus 2, it will be 0. And 2 minus 1, 1 it is. And 22 minus 9, 10, 13. This is 13. And 12 minus 8, it will be 4. So now here we need to find out the average turnaround time. So average turnaround time is nothing but sum of all these divided by 5. That is 11, 13, and 35, 35, 36, 37, and 47. 47 divided by 5. Once again, here we have a 2, 2, 4, 5, 6, 7, 8, 8, 2, so 16, 17, 17, 1, 2, 3, 4. Okay, 47 point divided by 5. That is, here it is 4, 5 eights are 40, 5 nines are 45, 9.4. And like that only, here it is 3, 4, 8, 9, 10, 11, 21. 21 divided by 5. So this is equals to 5 fours are 20, 4.2. 2, 4, 8. Okay. This is the average waiting time and this is the average turnaround time. Now we can compare among these. The previous one, here we have a waiting time 4.2, which is the preemptive SJF. And this one I have to make here SJF. SJF. Shortest job first. And like that only, this also I have to correct. It is not a FCFS here, SJF. Okay. And here it will be 5. And FCFS, it is of the 5.4. So this is the highest waiting time. And next, a non-preemptive SJF, it will be less than that of the FCFS, but more than that of the preemptive SJF. So then among these three, we have a more efficient algorithm is the preemptive shortest job first. I hope it is clear to you that these are very, very important algorithms. Along with this, we have some more, that is priority and round robin. We may continue in the further video. Thank you for watching.